Well, good afternoon. Welcome to the research panel on COVID-19 and the pandemic and the effects on school results. This panel is organized by INVALSI, and the coordinator is a good friend of mine, Andres Sandoval, who had an issue coming from the airport, so I'm covering him up. My name is Ernesto Treviño. And we will have 3 presentations today. We will have a maximum of 30 minutes per presentation. We're going to go over the presentation, and afterwards we will have a question and answer moment. So to start with the panel today, I want to welcome Lucia Schiavon, who is going to be presenting the impact of the COVID-19 pandemic on student achievement. And the head of every team that is presenting is going to introduce herself or himself and the team who is working on that. Thank you very much, Lucia.
Thank you. So, good afternoon, everyone. I'm Lucia Schiavon from the University of Verona, and today I am a postdoc at the University of Verona. Before I was a postdoc at the University of Turin, when I started to work together with Dalit, Contini, Tommaso, and Caterina Muratori, all from the University of Turin, and Daniela Piazzalunga from the University of Trento. And today I'm going to present a joint work with them. So the presentation is about the impact of the COVID-19 pandemic on high school students' performance after being exposed to a whole year of pandemic. So we all know that across the world, schools have been closed starting from spring 2020 in an attempt to contain the spread of COVID-19 pandemic. So by the end of June 2020, students experienced from 7 to 19 weeks of school closure, and while 1 year later, by the end of 2021, some students experienced up to 60 weeks of school closure. So this disruption have risen concerns about human capital formation, and due to skill loss and lower productivity, we expect a reduction of 1.5% of GDP per year for the rest of the century. In this context, Italy experienced a very long period of school closure, and it had a low degree of technological preparedness to support remote teaching and remote learning. Going in detail about the Italian context, since the study is about Italy. So in the first wave, in spring 2020, schools were closed for almost 15 weeks. And due to the complete school closure, the national standardized test INVALSI was not performed at that time, and no national intervention was implemented at a national level, neither during summer nor the following year. While in school year 2020-21, schools were closed depending on the number of infections recorded in a certain period and in a certain region. And in coming back to the national standardized test, they were performed in spring 2021. And also in the following year, that now there are available also the new data. So already several studies have reported declining achievements in for all students of all grades, and the learning deficit opened very early in the pandemic and remained. It was estimated a learning loss of 0.17 standard deviation. That if we think about the presentation of this morning, it's very a large learning loss. If we consider that in one school year, the learning gain can be considered about 0.33 standard deviation. So a loss of 0.17, it's about almost half of a year of school year. And there are also some evidence about large inequalities by socioeconomic background, especially for low-performing students. But we have some exception from this study, finding a mixed trend on this. About Italy, we have a couple of studies. Measuring the learning loss across the whole educational path of the students, and we can see that the large learning loss is on students of upper secondary schools, where Bazzoli and others estimated a loss of 0.32 standard deviation in math and 0.27 standard deviation in Italian. And this is a very huge learning loss. And also in the lower grades we find a learning loss, especially in math, and then we have some exception. Borgonovi and Ferrara instead find for grade 5 find that there is an increase in achievements for students both in mathematics, in math and in Italian. But this is an exception if we consider the other two studies. About heterogeneous effect, there is the study of Bazzoli and others that is going to be presented tomorrow here in the conference. They found that the learning loss has the same intensity no matter for the background of the students. Whereas Borgonovi and Ferrara found decreasing standard social economics status differential in achievements, especially among higher achievers, but this study is considering only primary and lower secondary schools. And so they also find a decreasing gender gap in math in grade 8 and a decreasing geographical differential. So with our study we wanted to contribute to this field of the literature by focusing only on high school students, assessing the learning loss in both math and Italians, and investigating learning inequalities by looking at a relative position of groups of students. And later we are going to see much in details why we suggested this. So first, for those of you who are not familiar with upper secondary school in Italy, so students at the end of grade 8, they have to choose which secondary school track to apply for to continue with their educational path, and they can choose among traditional lyceum, as humanities, where the focus is or in scientific topics or humanities, other lyceum, technical track, and vocational tracks. And students are free to apply to any high school that they prefer, and the recommendation of teachers are not compulsory, are not binding. So they perform INVALSI test in math and in Italian at the end of grade 10 and at the end of grade 13, with the exception of in the school year 2020-2021, INVALSI test was not administered in grade 10. We have to remember that it's very important that in grade 13 the math test is different in Scientific Lyceum. So we are taking into account this difference when we classify the tracks. So later we are going to consider Scientific Lyceum, other Lyceum, technical and vocational schools. So for our empirical analysis, we use, of course, INVALSI data. We refer to the full population of students. And here in the data set, the test score are standardized to have mean 200 and standard deviation 40. We rescale them to have mean 0 and standard deviation 1. And we restricted our sample to all the students who have taken the INVALSI test, both in Italian and math, and for those students that we also have the prior achievements records. So they completed the INVALSI test also in grade 10. And we consider two closed cohorts, the COVID cohort and the pre-COVID cohort. So to identify the impact of COVID-19 pandemic on school, on achievements, students, we defined this model that can be expressed with this equation where Y1IKJ stands for the test score in math or Italian performed in grade 13 of student I, of cohort K in school J. And with CK we define the dummy identifying the COVID cohort. Here it's important to know that we included school fixed effect. Why it is? Because this identification strategy it's very similar to a diff and diff model, but it's not. We cannot consider it as a standard diff and diff, since the test in grade 10 and the test in grade 13 it's different, and the two tests are not vertically anchored. But we consider that we consider very two close cohorts, and we add school fixed effect to increase comparability between the observation. So here we can have a look at the results. We find a very large impact of COVID-19 pandemic on both math achievements and Italian achievements. Here in the first row we have the estimation for math achievements, and overall we see that high school students of the COVID cohort suffered from 0.39 learning loss in math. And while in Italian it's very close, but it's even larger, of 0.41. They are all significant, the coefficient, also when we consider all the tracks separately. The sites very close. It's just the vocational students seems that They are suffering a little bit less, but still it's very large, the coefficient. However, we have to recognize that this model suffers from a big drawback. That is to say that we are comparing the results, results in achievements measured in grade 13 when the tests are anchored, so they are comparable, directly comparable, while controlling for prior abilities measured when students were in grade 10, but at that time the tests were not anchored. So we include in the model a relative measure for prior abilities of students. And this may lead to some bias in the estimation that we have just seen. So to investigate educational inequalities, we decided to propose a different model, reasoning on the relative position of a group of students, defining, considering every time different characteristics. In the model we control for all the characteristics, but then we are going to see the results considering one characteristics per time. So we decided to standardize the test score within the cohort for the test in grade 13 and in grade 10. So the expected value of the standardized test score it's equal to 0 for the one in grade 13, and also it's equal to 0 for the one in grade 10. So we can define the test score, the standardized test score achieved by a student in the pre-COVID cohort with the first equation. And it's very similar to the one of students in the COVID cohort. Well, we just see, we refer with different coefficient. So if we combine these two equations, we can rewrite the test score achieved in grade 13 with the following equation, where our coefficient of interest are represented by the difference between gamma 1 minus gamma 0 and lambda 1 minus lambda 0, all the coefficient of the interaction term between the COVID curve, the dummies that the student belong to the COVID curve, and other characteristics of the students. So we are going to investigate the differential effect on learning due to COVID-19 according to some characteristics, in details prior skills measured when they were in grade 10, macro region, so north, south, center, gender, parents, education, and a migratory background. So we start to have a look to the results, analyzing heterogeneity by prior skills. Here on the right we have math, like on your left we have math achievement, and then on the right Italian achievements. And the last row is going to represent the estimation for the overall, so consider all tracks together. And we can see that inequalities by prior abilities increase. That means that high-performing students, based on their position in grade 10, gain position in relative term respect to low-performing students. And we can see it in all the tracks, both for math and Italian. Then from now on we are comparing the estimation obtained from the model when we control for prior skills, prior abilities, that they are the red points. Here we have with Z0, and the one without prior abilities. This is because the red points give us the estimation of the changes in relative position due to the pandemic, and but considering fix the prior abilities, but assuming that in each group we have the same distribution of prior abilities, but this is not the case. And overall, what we can see in, if we want just to have an idea on how these groups of students change in their position, we have to have a look to the blue estimation. So that takes into account also the composition effect, that maybe here, for example, we have that girls and boys, but we are going to see better later on this difference. So because here the red points and the blue points are almost always very close to, or at least in the same direction. And we have that girls improve their position both in math and in Italian, but with respect to boys. But this means that if they improve their relative position in Italian, the gender inequalities increases, because in Italian they used to outperform boys, while since there was there is a gender gap in math, having improved their position make the gender gap decreasing, so gender inequalities decrease. And here we see it for all the tracks except for scientific lyceum in math. So the analysis on high and on students with high and low educated parents, it's very interesting, since that we see that overall students with high educated parents have worsened their relative position. It's not so. Okay, you can see it here. Very small, but they worsen their position, especially in Italian, and a little bit also in math, but very small. If we have a look to the blue dots, the blue line, we see that this effect disappears. This is due to a composition effect, because when we do not control for previous prior abilities, we found that no effect is evident, because usually high-performing students are the one that they are more likely to have highly educated parents. So even if the one with high educated parents worsen their relative position, we remember from the first figure that the high-performing students were the one gaining position over the low-performing. So moving to geographical differences, we see that here we have a comparison between south and north. We see that if we control for prior abilities, southern students relatively increased their position in math and in Italian. But since the south used to perform worse when compared to the rest of Italy, this effect disappears when not controlling for prior abilities. And we have the last plot over here. We see that migrants better their relative position, especially for Italian, with respect to natives. But then, without controlling for prior abilities, inequalities tend overall to increase rather than decrease. And this is due to a composition effect, again, but since native students are usually the high-performing one. So to sum up, in Italy we also we found that the COVID-19 pandemic had a negative and significant impact on students' achievement, and this is around minus 0.39 standard deviation in math and minus 0.41 standard deviation in Italian. And with the new data collected in 2022, INVALSI also pointed out that it seems that there is no recovery of learning loss in school year 2021-2022, if I'm not wrong. And these are very large learning loss, and they are quite alarming for their size. Anyway, our investigation suggesting a different model to also addressing the problem for not having anchored the test in grade 10 leads us to find large inequalities in terms of initial skills, but even less than expected due to about socioeconomic background of students. In relative terms, we can say that who lost ground were low-achieving students, so inequalities increased. Also, boys lost ground with respect to girls, and northern Italy, it is led to a decrease of inequalities. And here it seems from our results, native should have lost ground with respect to migrant, but due to composition effect, we do not observe real changes, relative change in the position of these students.